Whoa, is that Lex? It's Astrostetics. Let's get it, baby. Is that him? Everybody's favorite? Ladies and gentlemen, today we about to get into this annular solar eclipse. I hope y'all all feeling great and lit today because we're going to get into what exactly happens during an eclipse. And we're going to break down all of them, and we're going to use the sun, the moon, and the earth to do it. I hope y'all ready, because let's begin. And make sure y'all pick up a copy of Astrostetics as well. All right, this book is 500 pages and tells you everything you need to know about astrology. Link below. Let's get it. So y'all, during an eclipse, we have the sun. And y'all, excuse my drawing, right? So a diagram, all right? Just bear with me, all right? Y'all gonna get the idea though. So we have the sun here, and the sun is your light source. Then we have a body in the middle, and for the sake of this, let's use the moon. So we have the sun's light reflecting off the moon, and what this does, this reflects off the disk of the moon, and this here, we have an eclipse that quick. Now, what's interesting about an eclipse is that eclipses, they cast a shadow, all right? So the sun, let's write it down. Excuse my marker, y'all. The sun is our light source, all right? So we know that the sun, the solar system, Astrostetics goes into how the sun is the king of our solar system. It's called the solar system. So the sun's light and the mass of the sun is essentially what creates the solar system. So all light is created from the sun because the sun is a star, all right? And once again, these are one of the things that separate planets from stars. Stars create their own light because they undergo nuclear fusion, all right? So we have the sun here, and we have the light reflecting off the body in the middle. And this is what happens. You see the light coming in. The light, it reflects off the top limb of the sun, and then it hits the planet. And then this here casts a shadow. All right. Now this right here, this light is being reflected on the other side of the planet, right? And then this creates a shadow here. Now, when you're dealing with an eclipse, you have three parts of the shadow. So for the sake of this is the moon right here. All right. In the middle, this is the moon. And I'm going to tell y'all something interesting about the moon as well. But with the moon shadow has three sides, three different parts of the moon shadow. You have the umbra right here. This is the umbra, all right? So, and I'm going to explain what all of this means. This right here of the eclipse of the shadow, that's called the umbra, all right? And then after the umbra, you have the penumbra, right? So you have the umbra, the penumbra, and remember, all of this is coming from the light from the sun reflecting off the moon. Alright, so you have the penumbra here, the umbra here, and then right here, you guys see this part of the moon shadow right there, the last part of the moon shadow. This is where you would have the antumbra. So what you're dealing with here is the moon shadow during an eclipse. An eclipse has three parts, right? So when the light from the sun hits the moon and it bounces off of the moon and it travels through the moon, because the moon is gonna bend the light, and the light is so dope and intelligent. Make sure y'all pick up Astrostetics, that the light might also go through the planet, but the light is gonna get around it. Either way, it's gonna bend through it, go through it, right? We know how intelligent light is. And when this happens, this creates a shadow. So this is why when you're dealing with eclipses, you're always dealing with shadows, all right? And that's what you're dealing with this. So the moon it's gonna cast the umbra, right? Now, when you're in the umbra, this is what you will call the totality. So if a solar eclipse is going on and you're in the middle of it, you're in the middle of an eclipse and it looks completely dark, that's because you're in the umbra. You're in the part where the umbra, the umbra of the shadow is being focused on where you're at. So that's why that's what you will call a total eclipse, right? Now, when you're in the penumbra, the other part of the moon shadow, you're gonna see a partial eclipse, right? You're gonna see a partial eclipse when you're in the penumbra. All right, so let's do this real quick. Let's start from the top. We got the sun, we have the moon in the middle, and the sun's light is bouncing off the moon, and the light is bending off the surface of the moon, and then this creates a shadow. And the parts of the shadow that we have is the umbra in the middle right here, and then we have the penumbra right here. You feel me? We have the penumbra right there, and here, now look, there's a third part. And this is very dope right here. All right, make sure y'all subscribe if y'all enjoying this. All right, make America flex again, cause it's a flex again. So y'all look, you have the umbra, which is the point of totality. Then you got the penumbra, which creates a partial eclipse. Yo, this marker is acting real thotty on me, all right? But you got the penumbra, and if you're in the penumbra, you're gonna see a partial eclipse. And now, if you're in here, in the next extension of it, you're gonna see an annular eclipse. You're gonna see an annular eclipse, ladies and gentlemen. And that's what's gonna happen if you're standing in the other extension, which is called the antumbra. All right, so we have the antumbra. I'm gonna write it there for y'all. So the moon shadow has three parts. It has the umbra, the penumbra, and the antumbra. All right, and we know that depending on where you are, the moon shadow can move 2,000 miles per hour, 2,200 miles per hour. The moon shadow varies depending on where on the earth you're situated. All right, now look, when you're in the annular eclipse, you're gonna see the ring of fire, or you're gonna see an annulus, right? The annulus. And the annulus is a translation for ring, right? So you could change annulus to ring. And this is what we will also call the marriage of the sun and the moon, right? Make sure y'all pick up a copy of Astrostetics, all right? Make America flex again, because it's a flex again, all right? Now, seriously though, this is what we would call a marriage of the sun and the moon. When you have a beautiful eclipse like that, and the sun and the moon, they're yoked, we also call that astronomically a syzygy, all right? So the sun, the moon, and the earth, when they're yoked together or they're in a straight line, that's when you get an eclipse. But depending on how close the moon is to the earth, that determines the size of the moon. And the moon happens to be fairly close to the earth during the time of this next eclipse. So it's gonna look like the ring of fire in South America. For this particular eclipse, they're gonna be able to see the ring of fire, all right? But most of the eclipse is gonna take place in the Pacific Ocean, all right? So I think Hawaii and some of the Pacific Islanders, hey yo, shout out my Pacific Islanders, them. The Pacific Islanders gonna be able to witness this annular eclipse in Libra, but it's mostly gonna be focused on the Pacific Ocean. Pacific Ocean, I've been having a lot of activity down there. What's going on? All right, but see, when you're in the annulus, you're in the ring, all right, of the eclipse, and that's why it'll look like a ring of fire, all right, and that's when the sun and moon are married. All right, hey yo, can y'all read my handwriting? Oh, my fault, y'all. I hope y'all could read it. But if y'all can't, let's do this one more time. So during eclipse, any eclipse of any kind, you have the sun. And remember I said that I was going to tell y'all something interesting. The eclipse, you can replace the moon with the earth. All right, because when you have a lunar eclipse, when the moon is being eclipsed, the earth is actually, it changes place with the moon in terms of it being in front of the sun. All right, so that's important for y'all to know that would happen. So if you was on the moon, you would probably be in the point of the earth's shadow. And when it is a total a lunar eclipse, you could see the earth shadow on the moon. But remember, the light is always coming from the sun. All right, because the sun is king. All right, the sun is king. All right, because the sun is a star. It creates its own light, and all other bodies borrow their light from the sun. Okay, y'all? And when you're having an eclipse, you have the sun, and then you have a body in the middle, and that body is reflecting the light from the sun. And the light is going in all directions, but it's bending off of the planet or the body in the middle, because they're in a straight line. All right, and that's what's happening during any eclipse of any kind. All right, so this is a pretty a general video of what happens during an eclipse. And you know what else I wanted to do for y'all too? I wanted to show y'all the eclipse from another perspective. All right, so we gonna break down what an eclipse look like from another viewpoint as well. So let's say that I hope y'all enjoying the video. Make sure y'all subscribe. All right, make America flex again, cause it's a cause it's a what? All right, y'all. So let's say you're standing on the earth. All right, and look, if you are on the earth, make sure you like this video if you're on the earth. All right, so here we have the earth. All right, and remember, the sun is our light source all the time. All right, so we have the sun. We can make the sun really big in this case, and then we have the moon in the middle. All right, we have the moon in the middle. So y'all, we have the light coming in. All right, we know the light is coming in from all sides. We have the light coming in there. Yeah, excuse my writing on this, y'all. All right, and then we got the light coming in like boom, and then boom. All right, so when you're on the earth, this is what you're seeing. All right, so you're here on the earth, and the sun is doing the same thing again. All right, and then right here you have the antumbra. You got the penumbra, right? You have the antumbra, and you have the umbra right here. All right, so we're looking at the same thing as this, right? I put it back for y'all. We're looking at the same thing, but now you are here. Oh, ladies and gentlemen, my fault for that. My phone battery, it tapped out for a second, all right? But we're back. Now, y'all, look. What you're looking at is the same as the last diagram. It's just another perspective of what's happening during an eclipse. You feel me? So in the case of this, you are on the earth the same way, right? But now the moon is in the middle again, and the sun is being eclipsed. Now, when you're because this is what's really happening, but on this perspective, right? This would be the antumbra, right? This is the antumbra again. And this right here on the outside shadow, right? This is the penumbra again. So when you're in the antumbra, you're gonna see an annular eclipse, right? So let's say you're on the earth, all right? Now let me get rid of this so you can see what we're saying. Let's say you're in the path of the antumbra. You're gonna see an annulus. if you're in the path of the annular eclipse, you're going to see the ring of fire around the eclipse. All right. But now, if you're in the penumbra, you would see a partial eclipse. All right. But now, once again, if you're in the antumbra, you would see annular eclipse. But now, if you're in the umbra, if you're completely in the umbra, you would see a total eclipse. All right, you would see a total eclipse. So the antumbra and the penumbra, they are actually extensions of the umbra. All right, we got antumbra, penumbra, and the umbra. Okay, make America flex again, because it's a flex again. All right, so I hope this makes sense. And remember, we're looking at the same thing as we was the last time, but the last perspective was more like a side perspective, like a third person perspective. But now on this perspective, you are on the earth. All right, and now we're almost done, y'all. Okay, look, y'all, I gotta bring y'all to eclipse school. You feel me? This is what Pisces do. We gotta make sure it makes sense and make sure that it's relative to you. All right, that's why Pisces and Virgo are opposite signs, because Pisces is the imagination, Virgo is the analytical approach, the scientific approach. You mix both of these to, in a way, create reality, right? It's interesting. Make sure y'all pick up Astrostetics as well, all right? But now look, we have a third perspective of what's going on during an eclipse, and this is when we get very astronomical. So now, during an eclipse, right, this is what we're looking at. We have the Earth here. Y'all, excuse me for this. We got the Earth here, and we have the Earth's path of orbit like this. All right? And we know that the Earth travels on the what, y'all? On the ecliptic. All right? Earth travels on the ecliptic. And the planets and the sun, they also travel on the ecliptic as well. So we can put the sun here on the ecliptic. All right, this is the sun. All right, now the ecliptic, we gotta put the moon here. Now with the moon orbits, this is an astronomical fact. The moon orbits on the ecliptic as well, but its orbit is inclined by 5 degrees. All right, this is just a fun fact, but the moon travels on the ecliptic, but it has this rate of deviation of about 5 degrees. All right, and whenever these paths of the moon's orbit and the sun's orbit cross paths, this is when you get an eclipse. All right, so if we have an eclipse here, the moon is in front of the sun. All right, but remember, the Earth is in the middle. So when you're looking at it from this perspective, the moon's path intersects with the sun's path, and that's when the sun, moon, and the Earth are in a straight alignment. In astronomy, we call that a syzygy. All right, and this is an ancient Greek term for yoked together, right? So this perspective is showing you that the planets are yoked together. And when that happens, we witness that as an eclipse, all right? But remember, in our previous video about the eclipse, when the sun, moon, and the Earth line up like this is where you get the north node, right? So it could be any one of them, but for the sake of this, let's say that this is the north node. All right, so one of the nodes would be when the sun and moon intersect on the northern end, and then the north node and the south node, they're always opposite from one another. So on the opposite end right here, we would have the south node. All right, and that's why eclipses, and the north node and the south node are extremely important. And when you're dealing with the eclipses, you got to get astronomical with it, ladies and gentlemen. All right? You have to be and this is why helping diagrams help you. All right? And this is what I challenge all astrologers and astronomers to, always get in tune with a nice handy dandy diagram, my man. You feel me? And that's what we do. So, ladies and gentlemen, here you have, right, all three of the perspectives of what's going on during an eclipse. And this happens to be, like, in a way, a heliocentric perspective. But remember, we showed you the geocentric perspective, right, with the sun, moon, and the earth. All right. And then we showed you the other perspective as well, with the sun, moon, and the earth. And remember, all of these eclipses, they're all in a way the same thing. All right. The sun is creating the light, and the moon is going in front of the sun. Or in a lunar eclipse, the earth goes in between the moon and the sun. All right. And we know that the earth and the moon, the sun, all of these planets orbit in ellipsoid motions, which means that it's not a perfect circle. All right. And this is why the moon is at different sizes at different times during the month. This is why we don't have eclipses every month. This is why we have a new moon in different places. We have full moons at different times, because all of these bodies orbit in an ellipsoid motion, which is not a perfect circle. All right. But in astronomy, we'll call that like a eccentricity, and that's also called an ellipse. All right, which is not a perfect circular motion. All right. So y'all, I hope this video helps y'all for understanding eclipses and other aspects of astronomy. All right, and y'all know y'all rocking with Lex. Make sure y'all pick up a copy of Astrostetics. The book is over there somewhere, but we'll put it right here for you. All right, this book is 500 pages. We break down the eclipses and everything. Relationship astrology, astronomy, the houses. What do the houses mean? What do the degrees mean? When you look at a natal chart and you look at all the lines and you're like, what the bomba cloud is this? What are these lines and these triangles and these three triangles? What is that? Make sure y'all pick up Astrostetics, because this book is created to help you with that. All right? Y'all know it's Lex. Make sure y'all pick up a copy on Barnes & Nobles, and we revamping our website, by the way. All right? When we put that website back up, y'all gonna love that. All right? So stay tuned. Make sure y'all pick up a copy right now, and make sure y'all have a great one. All right? Y'all know it's Astrostetics. Let's get it. Make America flex again. Because it's a what? Huh? Because it's a flex again. Yeah. Peace, y'all.
Whoa. Head on over to BarnesandNobles.com, Amazon.com, and pick up your copy of Astrostetics, the Aesthetics of Astrology today. This book is 500 pages. If you're curious about astrology, this book is for you. If you want to know how to read a birth chart, master reading the natal chart, this book is for you. Relationships, compatibility, synastry, financial astrology, astrocartography. If you want to know where's the best place for me to move, relocational astrology is in there as well. Pick up your copy right now. Head on over to BarnesandNobles.com, Amazon.com, and order Astrostetics today.